Hi everyone, in this lesson we look at an example where we're told to determine the values of k in y is equal to negative x squared plus 4x plus k that will result in the intersection of the line y is equal to 8x minus 2 with the quadratic at 2 points and 1 point, and then we'll look at no points. So in this example we've got this constant k. Now we don't know what k is. It can be, it's essentially a variable. But we want to figure out the possible values that will result in this line having 2 points of intersection with this parabola. So let's look at how to do that. Well, we already know that if we equate, if we want to figure out the points of intersection between a parabola and a line, we can equate their y values. So we can say sub y is equal to, sub 8x minus 2 for y in y is equal to negative x squared plus 4x plus k. So we're going to replace y with 8x minus 2. And if we do that, we get 8x minus 2 is equal to negative x squared plus 4x plus, oh, this shouldn't be 4, this should actually be k. This should be k, sorry. So plus k. Now we can rewrite this equation in standard form. So if I rewrite it, I can write it as x squared plus 4x minus 2 minus k. Oh, I made a sign error. When you move this term to the left side, you're subtracting 4x from both sides. So we should have, oh, what? No, I didn't. Never mind, because I've got an 8x term over here. So if I subtract 4x from 8x, I'll get 4x. If I add x squared to both sides of the equation, on the left side, I'll get x squared. There's no other constant term other than k on the right side, so when I subtract k from both sides, I get negative 2 minus k. And that should all be equal to 0. So I want to figure out what values of k result in exactly 2 points of intersection. So here, if there's 2 points of intersection, then this equation is going to have 2 solutions for x. Well, when does this equation have 2 solutions for x? When b squared minus 4ac is greater than 0. I can use the discriminant, because I know that if b squared minus 4ac is greater than 0, then this equation will have 2 solutions for x. So the tricky part here is determining what a, b, and c are. Okay? So first off, a is going to just be equal to 1. That one's easy, because the coefficient on the quadratic term is just 1. The coefficient on the linear term is just 4. So b is going to be equal to 4. And the coefficient on the, well, the constant term, our value for c is a little bit trickier here. C is going to be minus 2 minus k. Okay? And that's because if I add negative 2 minus k to the rest of this, to x squared plus 4x, I can replace negative 2 minus k with c, and negative 2 minus k is the constant term in this quadratic equation. So let's now write out the discriminant. Well, b squared minus 4ac in terms of our numbers and our constant k would be equal to 4 squared minus 4 times a here is just 1, times c, and c is minus 2 minus k. So b squared minus 4ac, if I simplify this, well, 4 squared is 16, minus 4 times 1 is just negative 4. So I'm distributing negative 4 into negative 2 minus k. Well, negative 4 times negative 2 is positive 8. Negative 4 times negative k is plus 4k. So b squared minus 4ac is equal to 4k plus 24. Now, what we're trying to solve is we want to know when is the discriminant, for what values of k is the discriminant greater than 0. So we know that the discriminant is 4k plus 24. So we want to know when 4k plus 24 is greater than 0. So we can solve this inequality. We can subtract 24 from both sides of this equation, and we get 4k has to be greater than minus 24. I can divide both sides of this inequality by a positive number, and I get to isolate for k, and I get that k has to be greater than minus 6. Now, I don't need to flip the inequality when I'm dividing both sides by 4 because I'm dividing both sides by a positive number. If I had a negative coefficient beside k and I were dividing both sides of an inequality by a negative number, the inequality flips. So, and if you think about it, this makes sense logically. Think about the statement 5 being greater than 4. If I multiply both sides of this inequality by -1, or if I divide both sides by -1, then I would get -5 is less than -4. So that gives you some intuition as to why you need to flip an inequality when you divide both sides by a negative number or when you multiply both sides by a negative number. So moving forward, it says determine the values of k that will result in the system of equations having one point of intersection. So in this case, we know that b squared, our discriminant, b squared minus 4ac should be equal to 0. So if b squared minus 4ac is equal to 0, well, our discriminant in this case is 4k plus 24, and 4k plus 24 would be equal to 0. If you solve this equation, you get that k is equal to minus 6. So when k is equal to -6, that'll result in the system of equations having exactly one point of intersection. And lastly, for no points of intersection, well, for no points of intersection, our discriminant b squared minus 4ac is strictly less than 0. So our discriminant was b squared minus 4ac was 4k plus 24. So 4k plus 24 would have to be less than 0. When you solve this inequality, you get 4k is less than minus 24. You can divide both sides of this inequality by 4, and you get that k has to be less than minus 6. So when k is less than -6, you'll get no points of intersection to the system of equations, or for the no points of intersection for the line and the parabola.